A computer that thinks in ways we can barely imagine. Not with ones and zeros, but with qubits, tiny particles holding endless possibilities. Quantum computing isn't just faster, it's different. And it could change everything. Traditional computers store information as bits, a 1 or a 0. Everything you see on your screen, every app, every game is built from these bits. But qubits, quantum bits, are different. They can exist in multiple states at once. One qubit can be both 1 and 0 simultaneously. Multiply that across thousands of qubits, and the possibilities explode. It's not just more powerful. It's a completely new way of thinking. Two of the quantum rules that make this possible are superposition and entanglement. Superposition lets a qubit exist in many states at once, like spinning in multiple directions at the same time. And entanglement links qubits together no matter the distance. Change one, and the other reacts instantly. Albert Einstein called it spooky action at a distance, and he wasn't wrong. These principles allow quantum computers to process vast numbers of possibilities in parallel, something classical computers can't do. It's not just faster. It's a new kind of thinking, one that doesn't follow our logic but rewrites it. So why does this matter? Because it could solve problems we've struggled with for decades. From simulating molecules for new medicines, to cracking codes, to optimizing global logistics, quantum computing could dwarf today's machines, not in size, but in scope. Imagine designing a drug, not in years, but months, maybe weeks, or solving climate models with a precision we've never had. The potential is enormous, and we're just scratching the surface. It isn't magic. Qubits are fragile. They lose their state easily. They need extreme cold near absolute zero. Error correction is a huge challenge. And building a quantum computer with thousands of reliable qubits, that's still incredibly hard. But progress is accelerating. Companies and universities are pushing the limits every day. Quantum computers won't replace our laptops or phones. They'll complement them, solving problems classical computers never could. The next decade could bring breakthroughs that change medicine, energy, finance, even AI itself. And we'll be living alongside a new kind of intelligence, one that doesn't think like us, but in ways we are only beginning to imagine. Quantum computing, not just a step forward, but a leap into a new reality. And it's happening now. The future isn't coming, it's already unfolding. Be part of the shift. Subscribe for more.